Chapter 4. Very important things, as I said about Chapter 4, guys, is conductor sizes and types and the ambiguity for the conductors. We're going to focus slightly on the residential today, but I would go a little bit further because you're going to be with me for the commercial industrial, and I'm going to walk you through 310.15b16 how to use it to size a conductor based on voltage drop as well as based on the rating. So very, very important how to use it, and we're going to take a couple of examples. Neutral conductor sizing, we'll talk about this one too. So a few things, guys, determining the current carrying capacity of a conductor. This is not new to you. It will be new to some people next year, but we'll go to 310.16 and find the current capacity for the conductor. Understand the overcurrent protection device and the maximum they can land on the branch circuits. If you guys remember last week, I said you can't put an overcurrent protection device on a conductor if the overcurrent protection device exceeds the ambiguity of the conductor, with some exceptions. Motors are notoriously famous of that. Okay, so that's what we're going to be doing. Aluminum. When you have aluminum conductors, guys, we'll talk a few things. I don't focus too much on this because it's electrician work, but we'll touch on how do you terminate aluminum conductors. We all know if you terminate aluminum conductors, the lugs have to be rated for aluminum, right? Number one. Number two, if you have aluminum cover, you can't put them under the same lug. You have to have a lug specialized for aluminum cover. They put them one on one side, one on the other side, and they torque them. Because anybody knows why? Because they expand and contract at different levels or values. So when you expand and contract at different values, what's going to happen to the lugs over time? They're gonna loosen. What happens if you have a loosened lug at a 400 amp lug? If you have a current coming 400 amp, loosen, you're gonna arc. What does arc do? Big ball of fire inside your switchgear. So bad day for a lot of people. NEC requirements for all types of cables and raceways. This is a lot, guys, to cover today. So I'm just gonna touch a little bit on that. What the chapter takes an AM cable, ROMIX, MC cable, AC cable, and compare between these three cables. Then takes SE and USE, and take the EMT and the PVC and the rigid, all these conduits, and put them in one table and compare between them. So there's a lot of information here. We'll touch on as many as we can. Service entrance conductor, the user service entrance conductor, we'll do that. Voltage drop calculation, guys, we'll do voltage drop calculation a lot when we do in the commercial. So we'll do a voltage drop calculation. For the time being, I want to remind you, when we size conductor based on, if you guys remember, that three things. Number one, derating, if you need to derate. Number two, voltage drop. Number three, if it's continuous load. And we'll do a couple of examples on that one. Permitted to non-metal, bring non-metallic sheet cable into the top of the surface panels. Some of these are related to electricians. And stop me, guys, if I'm moving faster on these. Everybody knows that we measure the wire size in the U.S. with American wire gauge, AWG, right? Squared millimeters is how the rest of the world measure them. So you're going to find I grew up wiring 1.5 and 2.5 and 6 millimeters squared. So everybody knows that one. If anybody is getting into a project where you have to do the metric system, let me know. There's a lot of tables that take you from AWG into the metric system. Tons of really nice tables that get you there. Everybody knows, guys, the higher the AWG, the smaller the conductor in terms of sizes. And there's one little thing, you can get stranded, one strand or multiple stranded, but if you have a conductor, almost always the conductor that we use in a commercial, almost always conductor that we use, guys, in the commercials, almost always stranded conductors. Easy to pull through the conduits. For the most part, what we use in the commercial, in the residential, is non-stranded conductors, typically non-stranded conductors in the residential. If you are to put size 8 or larger in a conduit, it must be stranded. Only in a conduit. If it's not in a conduit, it doesn't have to be stranded. Typically, conductors larger than number 6 are stranded anyway. They make them stranded, larger than number 6, because it's easier. Everybody knows stranded versus, so here's a solid conductor, right? That's completely solid, stranded, and they make them a bunch of strands over here. That's your conductor. Why would you think they do them stranded? Ease of installation, and plus other things that the stranded conductor can do. Any comments, guys, about the stranded conductor? Carrying capacity, and this is where I'm going to switch you guys into the NEC code book, and I would like you to go with me into this table. Very important. So why don't you go with me to this table? This is where we're going to be using the table. Let's just look at this table here. Everybody's at this table. I would like you guys to write a few things on this table, once and for good. A few things on this table, once and for good. I want you first to put a divider right here. This and box these area here. I always box them. Conductors up to number 1. Conductors up to number 1. Up to size 1. Unless you know otherwise. Unless you know otherwise. Conductor up to number 1, you default to the 60-degree column. Can you guys see this is 310/16? 310/16, the issue with it is there's so many temperature rating. Let me just walk you very quick through 310/16, the limitation. This is only for 3 conductors carrying current in a raceway or a cable, or directly buried in air based on an ambient temperature of 30. Can you guys see that? And the voltage limitation of this boy is 2000. So if your system is more than 2000 volt, typically we use 600 volt here, you can't use this table. If you are other than a cable, a raceway, or in the air directly connected based on ambient temperature of 30, if you're other than these, this table cannot be used. Cannot be used. Everybody knows that? Cannot be used. So that's the first thing I want to mention right here from the get-go. The second thing I would like you guys to mention is, so there's the ambient temperature, 30. Then there's the temperature rating of the conductor. Insulation are rated based on the temperature. The higher the temperature, the more likelihood that the insulation will deteriorate. So the Smarter Than Chad came up with these 3 insulation. I'm looking at a copper here, the same thing in aluminum. 3 insulation you're looking at right in here. Can you guys see that? So you have a 60-degree, 75-degree, and 90-degree Celsius rated insulation. Everybody knows that? Okay, now with 60-degree, the 2 insulation that comes is TW and UF. Everybody knows that? And also an NM cable. They use, we're not talking about cables here yet. We'll talk about conductors. Under 75, here's all the insulation commonly used under 75. Under 90-degree, here's all the combination that you can use under 90-degree. Everybody can give me a thumbs up, Chad. We know that? Cool. So now let me tell you what you're going to be doing. You're going to be almost always using insulation that rated, especially commercial, rated for 90-degree. Almost always. Your insulation will be rated for 90-degree. Why? Because then when I deray it, I can get more amps out of the conductor. So don't even think of going there in terms of size of the conductor. So THHN is notoriously famous. THW-2 here, THWM-2, XHHW. These are typical insulation that can give you in a wet location or in a damp location, give you a 90 degrees Celsius rating for the temperature of the conductor. Any comments, guys, about this? Now let's go see how we use them. Here's the rules there, how you use them. Let me start with in red here. I'm going to start with the 75, and if you guys write them here, I'm going to say first, I is for amp. If your I is 100 amp or less, if you have a piece of equipment that's 100 amp or less, and you have no idea, Jeff, about the lugs on both sides, no idea. They don't tell you what the lugs are. What's your default? 60. From the get-go. Can I have a thumbs up, Chad? We got that one? Cool. Number 2, using this rule, if you have N is for insulation. Can you guys, I don't want to write here, N is for insulation. If your insulation is rated equal to 60-degree, then you are default. If your insulation is 60-degree, regardless of what the amp is, you have to be dumped right into this column. Can I have thumbs up, Chad? No problem. So these are, and the last insulation is 60-degree. The last one rule here is conductor, C-O-N, conductor. If your conductor is equal or less to number 1. You have a conductor equal or less to number 1. That's why I highlighted these up to number 1. Equal or less to number 1. You're defaulted to where? to the 60 degree, unless you know that the lugs on both sides of the conductor are 75. Can I have thumbs up that we understand the rules of using the 60 degree column? Everybody's okay with this? Okay, these are very important, guys, to know. Now let's go to the rules of the 75. The rules of the 75. You use the 75, default to 75 if your conductor is more than 100 amp. You have 100, 225 amp panel. Where do you jump? You jump immediately to the 75 degree column. Okay. You use them the same thing right here. If the insulation is more or equal to 75 degree. If your insulation is more or equal to 75 degree or more, you use 75. And the last one that we use them, if the insulation of conductor is more than number 1. So where's the conductor more than number 1? Right in here. A conductor more than number 1, what's your default? What's your default for a conductor more than number 1? 75. Can I get you to understand these? That will help you go through the whole year. This is the division between basically the 60 and the 75. Very, very important to know that. Repeat, piece of equipment less than 100 amp, you have no idea what the lugs are, you're going to default here. Insulation 60, you're here. Conductor number 1 or less, 14, 10, here. 60. Piece of equipment 100 amps or more than 100 amps, 75. Insulation 75 or larger, you're 75. And also if conductor is more than number 1, you're here. And right underneath the 7, can you also guys put motors? Motors are exception right under 7. If you have a motor, a machine, almost all the machines, they rate the lugs by default to 75. So we default to 75. Any question, guys, about these rules right on the 310.15b16? Very important. Now, Kerry, my friend, is looking there and said, well, why do we use 90, Chad? And oh, by the way, I'm looking at the copper side. Do you think the aluminum is different? It's the same. Aluminum is the same on the right side. These 4 columns here, 3 columns here on the right side are the same. Okay, let's go to the last thing. Let's go into the 90 degree. 90 degree here, I'm just going to go directly and grab the 90 and put the rules for the 90 here. You only use the 90 if the insulation equal or less than 90 or more than 90. You can't use a 90 if the insulation is not rated for 90, right? Don't even think about it, okay? And you use this one for derating. Derating only. Done. We do not size based on 90. We only derate based on 90. Cool? We don't size based on 90. We only derate based on 90. That's the rules that you apply for all these babies. Any questions, guys? Any comments? Any questions? That's very, very important to understand how to use this table from the get-go, because you're going to get very confused. When you guys do your journeyman, it's the same thing we teach. If they don't tell you what the logs are, that's your default. And all these are not, these are from 310.14, 314. All these rules that I gave you from 110.14. Let me just, so you don't think Chad brought these from his basement. I bring a lot of things from my basement. This is not one of them. All the rules are, can you guys put, this is coming from 110.14. All these rules that I went through, it's coming from 110.14 in the terminals. 110.14. If you read through the terminals, in particular, C1. Let's just put C and 1. This is where this is coming from. 110.14 C1. If you go read this, it summarizes exactly what I wrote here. Cool? So you know where to find this information. Any comments, any questions about this?
What was the third thing in the 75-degree column?
Motors.
What is the one just above that?
Above 1, if the conductor is more than number 1. Everybody knows the sign of a more and less, right? More than number 1, just to summarize. Okay, so these are how the rules of the 3 columns. Very important how to know the rules of the 3 columns. Now you work for Excel, young fella, right? You're an exception. The medium voltage, guys, medium voltage, we size based, our starting sizing is based on 90-degree column. They start the size based on 90-degree column. Only for medium voltage, higher than 600 volt. Now, most of you guys, probably 90% of the time, you're going to be working with less than 600 volt. So these rules will apply to you. If you deal, I want to remind you, especially for you guys, if you sit for your master, if they tell you the feeder is higher than 600 volt, then you size directly based on the 90. We do this in the industrial. We do sizing based on the medium voltage in the industrial. Any comments, any questions? Can I have thumbs up, Chad? We understand that how this works? Okay. There's one more rule in this table before we let it go. It's called the small conductor rule. The small conductor rule. Small conductor, these small conductors, and you see what these asterisks next to each and every one of these? Do you see them? Do you think why they did these asterisks right next to them? Because they're small conductor. These are, Jamie, the most commonly used branch circuits for lighting and receptacles. It starts with 14 all the way to number 10. The most commonly used branch circuits for receptacle and lights. 14, 12, and 10. Okay? Now we use, if you go to the parking lot, sometimes we use 4-aught to go there because of voltage drop. Because they're the most commonly used, they won't have limitation on them, right? Limitation on how much current they can do. So they call it small conductor rules. Small conductor rules. Okay, so I would like you guys to take, I'm going to go highlight these small conductor rules. The ones that I'm interested in is really these because you can't use right in here. Okay, everybody knows 14 through 10. These are small conductor rules. Small conductor rules, okay, 14 through 10. And right next to them, please highlight this column here. Okay, so small conductor rules, can you guys see that? Small conductor rules says number 14, no matter what your calculation is, everybody's okay with that, guys? Number 14, no matter what, you cannot land more than 15 amp circuit breaker or fuse on it. Number 12, no matter what your calculation come up with, cannot land more than 20 amps. Number 10, no matter what you came up with, you cannot land more than 30 amps on it. These are the small conductor rules. You're going to go in a situation where you start derating with number 10. Because look at this. I'm just going to take number 12. Look at number 12. Number 12, Ch can carry how much current? Can you guys see it? Number 12, Ch. How much current can number 12 Ch carry? 30 amps. Can I pull 30 amps of number 12? No. Why? Small conductor rules. Now, first, small conductor rules, and second, number 12 is the conductor less than number 1? Yep. So where's my default? 60 degree anyway. Cool. But here's what happened, guys. Suppose I started derating with now for derating purposes, number 12, I start with 30 amps, cut. I end up with 25 amps after I cut. Can number 12 carry 25 amps? No. Why? Two reasons. Number one, because 12 is defaulted to the 60, cannot carry more than 20 amps. The second reason is because number 12 cannot be, you can't put a circuit breaker higher than 20 amps on it. Small conductor rules. Any question, guys? Any comments about that one, the small conductor rules? If you don't understand these, you get lost in this table. You really do. So let's go to, and the small conductor rules is coming from 240.4b. So this one is not coming from my basement. It's right on the bottom, 240.4d or b? D. So if you guys go there, it will tell you exactly what I told you about these particular ones. This, it applies to 18 and 16. 18 and 16, guys, we use them only as fixture wires and class 2 and class 3 control circuits. We don't use this. Everybody knows branch circuit list and number 14 is not used. Any question? The same thing on this side, on the aluminum side, except they give him only for 12 and 10. Number 14 aluminum cannot be used as a branch circuit. Aluminum. Not like we use a lot of number 14 aluminum. Any comments, guys? Any question about how to use this table? Does it make sense? Let's take an example, very quick example, right from the get-go here. Just to summarize, we'll put it right here so we can be in this area. Example number one, guys, I have a panel, take a panel. I do have a panel, and my panel is 225 amp. I bought a panel, 225 amp panel. I'm gonna go and I put a 225 amp circuit breaker, and I need to go find a conductor to feed it. Anybody can tell me, and the conductors I'm using, all the conductors I'm using for all these examples is T, H, H, N, all of them, because that's a typically. Okay, can anybody tell me what the size of the conductor that I need for a 225 amp panel, which column and why? 3-aught, why? It's more, look at the rule, it's more than 100 amp, right? What's my default? 3-aught, here's a 3-aught, you come 3-aught all the way to, what did they say, 225 amp? What did you
90
get?
degrees.
Okay, who said 3-aught and who said 4-aught?
I said 3-aught. I said
3-aught. Okay, what's your default? 75 degree. Okay, 3-aught can 3-aught give you 75, 225 amp?
So
So where are you going to go?
Yeah, that doesn't have PHHM installation.
Here's mistake number one, Jeremy. We only use the 90 degree for what? Derating. Am I derating here? Can't believe how many times I've been teaching this one. People immediately jump to 90 degree column. No, we're sizing for a panel. So you either in the 60 or the 75. Only for derating we go to the 90. Am I derating? No, I'm sizing. So you're going to stick either 60 or 75. So what's the size? Number 4-aught, 4-aught. All right, example number 2. See how it jogs your memory? Okay, let's take this one. Now I have a panel, and I have no idea what the panel is, and I decided it's a 90 amp panel. 90 amp panel. I don't know what the lugs are. They didn't tell me anything about the lugs, but they tell me it's a 90 amps and it's CHHM conductor. Don't know anything about the lugs. Okay, anybody can size. Where should I go and why? I want to go to the 60. Why? Rule number 1, 100 or less, right? So what's for 90? Number 2, thank you. That will give me number 2. Are you guys following? Everybody's okay with that? Does that make sense? Number 2. Number 2. So let's take one more example. 3. Example 3. I have a panel, and my panel is let's say 300 amp. 300 amp. And my panel, and I decided because of some issues, I single-handedly decided to use a conductor of TW. It's a 300 amp panel, but I'm going to use a TW. Which column am I going to go and why? 60. Why? TW is rated for where? You see where it says TW? It's rated for 60. Is there a TW here or here? So my insulation is 60. That's rule number 2. Insulation equals 60. It's not higher than 60. So under 60, so I need 300 amp panel, insulation of this. So that will give me right in, where are we here? 300, it's going to go right there. Right? 300 amp panel, that will give me 300. Number
500 amp.
KCL. Right? Am I doing right? 300, see the 300 give me this one here, which is, no, 300 wouldn't give you that. No, thank you. I just can't read it from here. So 300, you have to almost go to the 500. Number 500 amp. 500 amp. That would be a bad idea, right? That's why we use the HHN, right? See why we use the HHN?
500 amps or 500 kCl?
500 KCM. Amps, Chad. Where did they get the amps? Thank you. KCM. Any question, guys, about these rules? Any question about the rules? Before we even get there. So that's basically the rule of, let me see if I can take a snapshot of that. Okay. So that's the table. Any question guys about this table? Now I'm going to take one example about the rating, and then I'll jump into a different table. So really straightforward, no gimmicks to it. Take one example about the rating. So here's the rule for the rating before I start. The rules for the rating. First, you start the rate based on the insulation rating, so THHN 90. Cut. Then you apply the rules of that particular conductor. The rules of 60 or 70. And make sure you don't exceed the rules of 60 or 70. Let me see here if it's fit it. Okay. No way. Let me take it. All right, so got snapshot on that boy. Okay, so I want to get rid of this. Oh, okay. So let me, before I go, I closed it now. Go back to okay, PDF. Back to my cables. So 310.16. I'm going to do one example about the rating, guys. So when we go to the rating here, and you'll hear there are two. Can you guys go to these two tables? The rating. I'm going to do an example based on the rating. Everybody knows what these tables in the code. There are two tables in 2011. Table number 1 is based on 30 degrees Celsius. The one that you use with 310.16 is this table, 310.15b16. The table that you use with 310.15b16 is this table. Why? Because if you guys go to the bottom of that table, it will tell you this is the one, this is the rating table that you need to do. Cool? This page is, this one is in page 150. Page 150. Cool? Everybody's there? Let's take a derating problem. Let's take a derating problem and see how we're going to size that derating problem. Derating problem. Let's okay. For derating purposes, I'm going to use how much current conductor can carry. Let me start with say I'm going to use here's my example. I conduit. Here's my conduit. Cool. Here's my conduit, and I have conductors inside these conduit. They're all phases, all 3 phases. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 conductors. 12 conductors at number 10, A, W, G, T, H, H, N. I have 12 conductors, all of them, right? 12 conductors. All these conductors are going branch circuits to feed machines. All of them are 3-phase, carrying current, 3-phase. 12, that will give you what? 4 circuits, 3-phase, 3-phase each, right? Going to the machines and feeding them. All in one conduit. 12 of them, THHN. Cool? And I want to see how much current THHN under these circumstances can pull under these circumstances. Okay, so here's what you're going to do. We're going to take number 12. Since it's THHN, THHN, you're going to go to the 90-degree column. With me? How much current THHN number 12 can carry? I can tell you 30 amps. Why did we go to the 90-degree column? Because we're derating. Cool? Everybody can give me a thumbs up, Chad? We know why we get that. Why did we go to the, because it's THHN, you go to 90 because we're derating. Cool. Now go to table, there's a little table you guys remember with table 310.15b3a. It says if you have more than 3 hots, you have to derate. How many hots do we have? 12. So 12 hots, it says 10 to 20. Everybody can see how much? 10 to 20? How much? 50. So for 12 conductors, my derating factor is 50%. Which table is that one? This is 310.15b3a. 310.15b3a. Cool? Everybody got that one? Cool. Now let's go do the math. So here's, oops. Oh, no, don't run away from me. All right, so let's do the math. We're in here. So we got the 50, which is 0.5. You multiply it by current conductor of what? Let's say, so we have 30. So how much current this cable can carry now? 15 amps. 15 amps. 15 amps. It went way down here. 15 amps. Everybody is okay with that? 15 amps? Okay, 15 amps. Where did I go? Where run away from me? Okay, here you go. 15 amps. All right, so I want you guys to go to, before you leave, before we leave this calculation. Okay, here's my calculation. I came up with 15 amps.
How did you get the 30 amp?
The 30 amps here, right here, number 12, under 90-degree column, give you what?
I thought we were using number 10 AWC.
Was it number 10 that we did?
Yeah. It's written right there, yeah.
Oh, man. Okay, I'm sorry. This would be then 40, thank you. And this will be, thank you, 40. And this will be 20. Thank you, 20. I looked at the number 12 instead of number 10. I should have used number 12 because it's... Okay, 20 amps. Everybody got that calculation? Thank you. Good point. Now, am I done? Am I done? This is where a lot of people get confused. Am I done? No. Here's what you need to do. You're going to go under normal condition. How much current and how much number 10 can carry under normal condition? Can you guys read that one? 30 amps. Under normal condition, number 10 can carry 30 amps. 10 under normal condition, which is 60-degree column, can carry what? 30 amps. Now, Jeff, have I exceeded what number 10 under normal condition can carry? Have I exceeded that? No, then we're good. If you did exceed, which it could happen, so if after you derate it, you end up with 35 amps. Cool? After you do it. Could it happen? Yeah, because we started with 40. Cut. We cut it a little bit. It became 35. Can I use 35? No. Why? Because the normal operating condition for this conductor it does not allow it to carry more than 30 amps. Does that make sense? More than 30 amps.
Why did you always default to the small connector at the end of the day? Right?
Yes, number one. And number two, you still have to default to the conditions that we wrote about the 60 and the 50 for sizing. Regardless of what you come up with, you have to default to the 60 and 75 rules that we went. So if you derate and you end up with a number that's higher than what the 60 or 70 can give you under their circumstances, you have to stick with what they give you. Then remember, the 60 and 70 is normal operating condition for the conductor. The derating is supposed to give you the normal operating condition or less, not more. So if that makes sense. So that's derating. Let me take a snapshot here. Okay, so that's my, let me go back into, any question guys about this before I go back into my derating based on temperature? I want to go to derating based on temperature. Erase this stuff. So based on, we got that one, right? So we'll go, now I'm going to go to, let me erase that one and have one example based on temperature. And then you guys, based on both of them, you just multiply for both of them. Okay, so since we're on the temperature side, and by the way, my junk that I'm doing, when I take a snapshot about it, I PDF it and put it in the network for you. So that's what the snapshot does to you. Okay, get rid of it here. Okay, let's take very quick, guys, this conductor. I want you to look at this. I have 4 off. 4 THHN, and the ambient temperature for this place is 50 degrees Celsius. I put a 4 and a 50 degrees Celsius. CHHN. I need to find how much current this conductor can carry if you put it. Typically it's rated to be put on a 30 degrees Celsius. If I put it in a 50 degrees Celsius, right in the middle of a desert or somewhere, a furnace room, how much current this conductor can carry? Let's go do that. Can you guys tell me? So if you take the 4 which column are you going to go and why? For the rating, where do we go? 90 degree. How much current number 4 can carry under 90 degree? Anybody?
260.
I need a second. 260. 260. Under the 90 degree column, right? Okay. Now, do me a favor. I want you to find the same conductor. What's the typical operating current for 4 The normal operating condition for 4 How much current 4 can carry under normal operating condition? Thank you. 230. 230 amps. So now, Brian, no matter what I come up with, can I exceed the 230? No. Everybody's with me? Can you guys give me a thumbs up, Chair? We get that one? You can't, under no condition, you can exceed the 230, the normal operating temperature, which is coming from 75. Okay, so let's go start the rate. Celsius, where are we here? You guys familiar with this table, new table? Did you do the 310, right, with Gary? It was 2011, I mean. 2011, the code, yeah.
Yep.
So here's a Celsius. I picked a Celsius, so I am 50, so I'm here. Everybody knows how to use Celsius, that table. My insulation is 90, and I'm at 50 Celsius because Chad said so, at 50. So cross-reference the two together. What do you get? 0.82. Anybody does not know how to use this table? You graduate from Dunwoody not knowing how to use it, ask for refund. Anybody does not know how to use it? Really straightforward. Here's the temperature, and here's the insulation. If I was using, look at that, Darren, if I was using instead of THHW, THW, which column am I going to default to now for the rating? 75. If the insulation was not THHN, it was THW, then my column for the rating is going to be 75. God forbid if I use TW. Say if the insulation here was TW. Which column am I going to be defaulting for the rating? 60. And which column am I going to get the ambiguity from if the insulation was 60? Both these ambiguities. Which column? 60. So see what the insulation is very important. That's why 99.9% of the time, guys, you're dealing with THHN, THHW, 90 degrees. So whatever you do, you still have good juice in your system. Okay. So 0.8, I need somebody to do the math for me. So I'm going to take a 0.82, multiply it. I need somebody to tell me which one are you going to multiply it by and why. By 230 or 260? Why? Thank you. We're derating. If we're not derating, you stick with 230. So let's do that. 260.
Come up with 213.
213.2 amps. Okay, now, here's what I would like you guys to do. Does this value exceed this value? If it did, what would you do? 230 no matter what. Can I get you guys to understand that one? The rating's supposed to come up with a value equal to this or less, not more. Same thing for voltage drop. When you guys go do voltage drop calculation, size of conductor for a voltage drop, if you do a math, do a calculation based on a 10-foot voltage drop calculation, you end up with a conductor number 14 can carry 50 amps. Can conductor number 14 carry 50 amps? No. Why? Because you still have to adhere to the rule 310.15b16. So these 60 and 75 rule. The exception is the derating. Any question guys about this? The exception is the derating. Does that make sense? Now let me just do this example, guys, with the same example with TH. I'm going to use the same example here, except I'm going to use TW. Okay? I'm going to use the insulation TW. So let's do the first thing. So 4 TW, which column are you going to go to? 60. Why? Because TW is rated for 60. Can you guys give me the amps?
195.
How much?
195.
195 amp. And how about for also for sizing? Same column, 195. So both of them are the same because we're in the 60 for sizing and the rating. Why did they go to 60 for the rating and 60 for sizing? Because insulation is rated for 60. All right, do the math. So for 60, so my insulation are rated for 60, and my ambient temperature is 90. Look how much you can cut. That's disaster. 0.58 versus what? 0.82. Okay, now do you have appreciation why we use the Ch-chan instead of THW? Okay, so here's the math. So my cutting factor is 0.8, 0.58 multiplied by 195. Can you guys tell me how much juice this guy's gonna have? 159.9 amps. The same size conductor can carry 213 or 159 or like 160. Do you see why we use the Ch-chan? Can I have thumbs up, Chad? We got it. See the power of using an insulation as you don't want to use THW, Ch-chan.
Those amps can't be right.
No, I think
It's gotta be around 113.
Yeah, I got
113. Okay, we have some issues with the math. All right,
That's about right.
113. Even worse, 113 now. Any second on that? Second 113. Okay,
That sounds way better, way closer.
closer to the yeah.
You're
When
almost
you're
taking
cutting it
half of
almost in
one
half,
half.
there's no way if we.
Yeah. Can I have a second? Just calculation mistake. Is it? Okay. 113. But
I did the wrong
the-
period back there.
that's all right. Not a big deal. So does that make sense though? Do you see the difference between these two? Do you guys see the difference? Do you see the difference? Okay, can I have thumbs up? We know how to use this table, right? And we use 3 to the 16. Okay, I'm gonna jump in and take a snapshot on that boy. And
You made the coffee this morning. Yeah, did you actually like put coffee in the filter or did you just run water?
No, it's just water.
oh shoot.
What a ball buster.
What?
What a ball buster.
Dude, I was thinking, I was like,
What happens when you get deep coffee in the morning, right?
That's why you gotta freaking chug it.
Yeah, and the espresso machine is down again too.
Okay, can I guys get you before I leave this subject? So can you give me a thumbs up? We know really how to use these tables, the rating, and we know how to use 310.15b16. Very, very important. You're going to hear me talk about these as we move on for the commercial industrial, the same thing. Okay, now, for those of you who are lucky in their life, they will be using this table, the lucky ones. This table. This table, this is based on 40 degree. There's if you have a boiler room that's always hot, guys, they use insulation that's higher than 90 degrees Celsius, and they call them high temperature conductors. Probably 5% of the time you're going to use this table, 5% versus the other one, 95. Okay, so I want you just to pay attention to a few things in this insulation. They added more temperature rated conductors. These are high temp. They call them high temp. High temperature rated conductors here. See 150, 200, 250. That's why this table is very important. Only 5% of the time. You're going to use it only if you have an insulation that rated for this value. I'm going to leave it as is, but I want you to be aware of, and this is for conductors rated, it's based on 40 degrees Celsius. So we never use this one with 310.15b16. Why? Because when they calculated the amps in 310.15b16, it was based on 30, not 40. These comes with a bunch of other tables in the code that we use them with, and this will be with table. Which table do we use here? Yep, this will be with table 310.15b18, And also we use it with 19, 18, and 19. Different table. I'm not going to touch on that one just because we're doing residential now. For the rating, as long as we're on it, I would like you guys to be aware of these two tables for the rating. If you're not aware, if you have not highlighted this table, please highlight it. This is if you have more than 3 hots. This is the table that you derate. For example, I have a gutter, and the gutter, I filled my gutter with 50 conductors, number 12. Gutter, you can fill it with 50 conductors, number 12. How much each one of these conductors is going to carry? 35. That's called full design, right? A fool would do that. So if you guys look at that, you almost would be a fool to go lower than that. You know, grouping conductors more than 9 carrying conductors in one conduit. Why? Because you lose a lot of juice if you go lower than that. You go higher than that, what happened? A conductor that can carry 1 amp, now it's carrying 50% of that, a half an amp. So design-wise, since you guys are designers, you're going to be putting close to 9, no more than 9 conductor in a conduit. And we typically do them in branch circuits. We don't use them in feeders. It will be a fool to put group feeders together, right? For two reasons. Number one, the rating, and number two, also for reliability of the system. Do you want a feeder to trip and take another feeder with it? So keep in mind when this is beautiful to look at, but typically that's what you're going to be using. You're going to be grouping up to 9 hots in one conduit. More than that, it becomes really tough to justify it. Okay, everybody knows how to use that one. Now, if you have this table, guys, and please highlight this one too. This table is if you put your conduits on the roof, commercial roof, like we do air handling unit, rooftop units, right? Rooftop units, air handling units. And if you put here's my roof, and here's my block, concrete block, and I put my PVC conduit right in here, and let's just say pick a value here, and my concrete block was 4 inches. 4 inch. So I raised it up 4 inches on a commercial roof. Then the ambient temperature here, the ambient temperature was, let's just say, let's use Fahrenheit. It was 100 degree Fahrenheit. And because I put them on the roof this way, these conduits will be cooked by 2 ways. One, direct sun rays on it. That's where the 100 Fahrenheit ambient temperature comes to play. And reflected heat from the roof. That's where this table comes. Okay, so it's 4 inches. If you guys look at this is from 1/2 inch to 3 inch. This is from 3.5 to 4. So we're right here. Everybody can see that's the height that you're doing. If you're right here, what's your adder in Fahrenheit? 30. They call it temperature adder. Okay, so what does that mean, Chad? It means you have to add another 30 degrees when you derate. So what's the ambient temperature now, corrected ambient temperature for this situation? 130. Then you go back to the table that we were in. Is that hard to use? Cool? Carry, my friend? So when you put your rooftop units now, chillers, cooling tower, be very aware of that one. That's what forces, I teach these for code update because that forces a lot of people when we design now not to run the conductors on the roof. Run them underneath the roof and poke right into the equipment. Because there will be a lot of derating involved here. So, because if you take it more than 4 inches, 6 inches, look at that. If you go 12 inches, you add 25 less, but 12 inches is high to sit on a roof for, say, 2 feet or so. Any comments, guys? Any questions about this one? Okay, so take this one as we go. Snapshot. All right, so last thing I want to show you guys is the one, since we're dwelling, we're moving a lot of stuff, but we're not doing the dwelling. The dwelling, there's a special table that we use for dwelling. Since we're doing dwelling, so you have to use this table and be aware of that. Okay, here we go. That's good enough. Okay, the last table I want to show you guys is this table. You guys familiar with that one? You've seen it. Here you go. So I want you guys to come over here and look at this table. Since we're doing dwelling, this is where you're going to be. This is the table they're going to be sizing for our project. So let me draw our project. Our project is going to look like this, guys. Meter center. This is my service coming in. This is my meter center. I'm going to have 1, 2, 3, 4, 5 panels. This is P1, P2, P3, P4, P5, and this is my meter center. This is your project they're looking at. The meter center, it's nothing but a box with a meter and a disconnect for each one of these panels. Overcome protection device, circuit breaker. That's how your project is going to do. When you size it, this is this a dwelling? First of all, ask yourself, this table is only for single phase. Is the system single phase? Yup, Chad, we're using, our system is going to be 240, my system is going to be 240/120 volt, single phase. Why would I use single phase 240/120? Because there's 240/120 three phase too. 240/120 single phase. So does this apply to it? Yep. Is it dwelling, Chad? Yep, it's dwelling. I want to highlight this: service and feeders. Okay, did you hear the word? A lot of it, think of it service. Is it feeders too? Yep. So when you guys size this, here's my service. And when you size 1, 2, 3, 4, 5, you're going to go to where? Are these feeders going all the way to the apartments? So you're going to use this table for service and feeders. The service coming to the box, the meter center. And out of the meter center, you're going to have feeders that feed these conductors. So that will be your feeders.
Are we putting the panels in each apartment? So
Yes. So we're going to put the meter sensor somewhere else, and we're going to pull basically feeder becomes, because the service coming in, we're going to meter them separately, but we're going to take the feeder all the way to each one of these apartments. Okay, so let's go use this table. Everybody can understand what the limitation of this table? Single phase dwelling 120/240. If you're using 208/120, do you see anything 208/120 here? Can you use it for apartment 208/120? No. This is a special condition table, very special condition table. Okay, so let's go size. Suppose that I can't put less than 100 amp in any dwelling, apartment or anything else. You don't want to put anything less than 100 amp. So suppose that I have 100 amp. What's the size cover? Because Chad is vested in the cover companies. 4. Done. Suppose I have a 200 amp. So suppose each one of these are 100, 100, 100, 100, and the main one was, this is 200, because that was like the house panel. What's okay? Let's go to the 200. Here's the 200. What's the size? 200. If you are cheap, Brian, my friend, and you want to use aluminum, what do? 4-aught. Same thing, 2-aught if you want to use aluminum. Can have thumbs up. Everybody knows how to use this table. See how easy that is? Piece of cake, right? Okay, so what happened if you go higher than 400 amp? They shifted you back into 310.15p16, the one that we were looking at. Any question, guys? So limitation, look at the limitation on this table. Up to 400 amps. So that's, you're talking about apartments, quads, not high risers, because high risers, you end up with higher than 400 amp service. Can I have a thumbs up, Chad, that we know how to use this table and we will be able to use it for our project? That's where you're going to be using it. I want you guys to keep in mind, let me take a snapshot of it and go, what if that was, the voltage is different, and then take snapshot. And now I'm going to take you back with the same junk here into the second table. Okay, let's go. Can you guys, I'm going to overlap it on the second one and see, I'm going to use the same calculation here. If that wasn't 2, it was 28120. So let's just say that was a 28120. 208/120 volt. And that most likely would be three-phase system, right? Three-phase. Okay, where would you size? Now we moved the system, we made it three-phase 208/120. I can't use the table that we were in, so we're here. So let's go size. First one is 100 amp. Can you guys size it for 100 amp without knowing the logs? I have no idea what the logs are. For the 100 amp, what the size would be? 100 amp. Number one. Now for the 200 amp, which column would you go to? 75. We just talked about 75. For 200 amp, number 3 out. 3 out. We're going to the 75 here though. Is that 3 out? 3 out. Done. See how the sizes change? What was the size that we came before? We came up with number 1. Number 4, see how smaller. And what did we size? And number 2, we moved up to 3 out. Why? Residential don't consume a whole lot of power, so they allow you to have a smaller conductor here. Any question, guys, about this? Any question? So that's what I wanted to highlight a lot before we move on this table. I'm going to give you a break. I'm going to stop today. I'll continue tomorrow with the chapter, with the other things. But I wanted to make sure that you guys understand this one fully before we go ahead. Especially the table that we did before. Can I have thumbs up, Chad? We got it? Okay. So let's stop right here. All right.